Good morning, students. Today class we're going to study about periodical properties. See the periodical property, the change in the property. Property is nothing but that already I told that physical and chemical property of an element in the periodical tables. We'll write that the change in property or properties of an element in the periodic table. The change in properties of an element in periodical table. Important periodical properties that are atomic radius. Second one is ionization energy. Third, electron affinity. Electronegativity, and last, valency. You see, these are the five important properties in the periodical table. First, we are going to study about that atomic radius. You see, the atomic radius means atomic is nothing but an atom. Radius is nothing but a size. We can also write atomic radius or atomic size. Okay, we can write both atomic radius or atomic size. We know that atom, it has a nucleus at the center. Around the nucleus, it has many number of electron shells. You see, we are taking this is a nucleus. We are having a many number of electron shells. Okay, you see the last shell, it is nothing but last electron shell is nothing but valency shell. Last second electron, we call that penultimate shell. Last third we call anti-penultimate shell. Okay, last one is valency shell. Last second it is penultimate shell. Last third is anti-penultimate shell. You see, what is this atomic radius? Atomic radius is nothing but a distance between the nucleus and electron which is present in valency shell. We'll write the definition. While definition we can know that. Okay, the distance between the nucleus and electron which is present in valency shell means you see this here the electrons are present, no? The distance between the nucleus and the last electrons present in the valency shell, okay, is said to be atomic radius. Can you understand this? What atomic radius? We'll talk next units. Units means based on what the atomic radius will be measured. Okay, it is first one is Armstrong. That is 1 Armstrong is equals to 10 to the power of minus 10 meters. Next we can use another unit also, that is a picometer. That picometer is nothing but 1 pm, nothing but 10 to the power of minus 12 meter. You see, we will talk some important points in the atomic radius. It is not possible to measure the exact position or exact radius of an atom. Why? We cannot measure. You see, every atom will be changing, no? The size will be changing, correct? No, it will be some elements will be small in atomic radius, and the clouds will be nucleus does not have definite boundaries also. Okay, we'll write that it's not possible to measure exact radius of an atom. Why we cannot measure the exact radius of the atom? First, in that why, first one, it is atomic size is extremely small. Some like hydrogen, it is 1s1, helium 1s2, lithium. Okay, like that atomic size is extremely small. We'll write the first point why we cannot measure the exact atomic radius, because the atomic size is extremely small. Second, electron cloud around the nucleus do not have definite, means it is not have a definite boundaries, not have a definite boundary. Next, third, difficult to isolate single atoms, means the atoms will be joined, for that single atom we cannot isolate it. Okay, difficult to isolate single atom. Next, atomic radius changes when atoms are bonded differently. Means you see, the atoms are bonded, means the atomic radius will be changes. Okay, you will write atomic radius changes when atoms are bonded differently. Why? The atoms, we cannot measure the atomic radius exactly, because it is the 4 points. Atomic size is extremely small. Atom clouds around the nucleus do not have the definite boundaries. Difficult to isolate single atoms. Atomic radius changes when atoms are bonded differently. Okay, next, factors which control the atomic radius, means factors which have the influence. Okay, we can write that also. Factors which controls atomic radius. Okay, in this first, number of electron shells electron shells will control the atomic radius, correct? No, number of electron shells. Second point, nuclear charges. Nuclear charge, based on the nuclear charges also, nuclear charges, it controls the atomic radius, because you see the nucleus having charges, positive charges, will attracts the electrons. We know that like charges repel, unlike charges attract, correct? No, yeah, unlike charges is there, it will be attract. For that we call that nuclear charge. Okay, nuclear charge, positive charge on the nucleus. Next, third, bond order. Bond order inversely proportional to atomic radius. If bond order increases, then atomic radius decreases. For example, we take carbon single bond, carbon double bond, carbon triple bond. You see here the bond order means bonded, how much it is having a single, correct? No, here it having double, it having 3, correct? No, if atomic number must be decreasing when bond order increasing. You see, when come to carbon single bond, here the bond order is 1, means less, then atomic radius will be more. Do you understanding here? Next, depends upon the nature of the atoms, either metal or non-metals, the atomic radius of different types. You see, the atomic radius having different types based on metal, non-metals. Okay, I will write that atomic radius of different types based on nature of the atom, either metal or non-metal. Okay, you see the first one types, that is covalent radius. Second one is covalent radius. Second one is ionic radius. Third one is metallic radius. Fourth one is vander Waals radius. We will study that each and every one, that is covalent, ionic, metallic, vander Waals. Okay, before that we will talk about variation of atomic radius in groups and periods. You see, we are going to study about variation of atomic radius in groups and period. Already I told you, if you take this is period, correct? In periodical, this period, it will be groups. Okay, the horizontal rows, it is nothing but a period. Okay, horizontal rows, it is period. That vertical columns we call as group, correct? No, we call that vertical column. Here horizontal rows. Okay, horizontal rows and vertical column. You see, while groups we talk in variation of atomic radius. In atomic radius, what happens in groups and period? First, we'll go to groups. In groups, the atomic radius, when coming top to bottom in a periodical table, top to bottom in a periodical table, the atomic radius increases. Atomic radius increases. Atomic radius, I will write like a symbol, increases. Okay, let us take how it increases. Okay, let us take for example, we'll take that lithium, correct? No, sodium, first group C, lithium, sodium, potassium, rubidium, cesium. Okay, if you write for lithium, it is atomic number 3, we will write that 1s2 2s1, correct? No, for this you see it having the shell, it is a diagram for lithium. If you write for sodium, for example, sodium it is 11, 1s2 2s2 2p6 3s1, correct? No, if you write for lithium, the diagram it is having 3 orbitals, that is 1 2 3. Okay, it will be, the radius will be increases, correct? No, the radius will be increasing while going from top to bottom. While going top to bottom, the electrons will be more, then the atomic radius will be also more. The distance between the nucleus and the valency of electrons, it increases. As result, valency of electrons, they are going to experience a less nuclear attractions. If radius will be increases, the nuclear attraction will be less. Okay, you understanding here? Atomic radius will be increasing, the nuclear force of attraction, nuclear force of attraction will be less. Why it less? The atomic size is more while coming top to bottom. Size increases quite commonly, that orbitals also will be increases, electrons will be more. See, it is third. If you go to down, it will be orbitals like it will be more. If it more means the distance of the radius will be more, then attraction of nucleus and the last electron present in the valence shell will be, attraction will be less. Okay, next we are going to talk about period. We talk on about the groups, now we are going to talk about period. You see, the atomic radius in a period will be decreases. If it increases, quite commonly opposite, it must be decreases. Why it decreases? You see, we will take that period, that is sodium, magnesium and aluminium. It is all in a third period. It's all in third period. I am taken only 3. Okay, if you talk that sodium, its atomic number is 11, magnesium it is 12, aluminium it is 13 atomic number. If you write the electronic configuration of this sodium, 1s2 2s2 2p6 3s1. When come to magnesium, 1s2 2s2 2p6 3s2. When come to aluminium, if you talk aluminium, 1s2 2s2 2p6 3s2 3p1. You see, while here the electrons in the sodium is 11, protons will be 11. When come to here, electrons 12, protons 12. Here we talk the electrons is 13, protons is 13. The third electron shell, you see the third, if I'm talking about, you see the third electron shell, this is first, this is second electron, first, second, third, your first, second, third. The third electron shell, I am talking that here, third electron shell, third electron shells, it is third pair, it having also in third electron shell, the nuclear charges increases because it is all in third orbital only. You see, third orbital means 1, 2, 3. It is all in third orbital. It is all in third orbital. It is quite common. It is decreases. Why it decreases? Nuclear charges means it attraction between the nucleus and the electron of the valence shell is increases because it is near. You understanding here? It's go on increasing the radius. It is 1s. It is a second, third, fourth, fifth, sixth orbitals. I'm talking that. If first you see it is going to 6 orbitals, for that it will be increases the atomic radius. Here the atomic radius is small. See 1, 2, 3. It is all in third period. It is in the third electron shells. It having nuclear charges will be increases. I will write here. Nuclear charge increases. Okay, next we are going to talk about the covalent radius. Covalent radius. You see, if we talk the covalent radius, covalent only for non-metals. You see, covalent, it is nothing but only for non-metals. Non-metals. Radius is already told that size, non-metal size. You see, we are going to talk about the definition. The definition is nothing but one half of the, going to first definition, I will write the diagram. You see, this is a one term, it is another atom. It is the radius, it is another radius, correct? No, this is nothing but distance between, this we call that a bond order, or sorry, bond length. You see, the one half of the inter, you see, I'm talking this distance I'm talking. The one half of the internuclear distance between internuclear, this is covalent radius. You see, one half of the inter, it is inside, no, inter means between that internuclear distance between two identical atoms linked by a single bond. You see, I will write the definition. One half of the inter, you see, one half, correct? No, it is will be half. I am taking half of the internuclear distance between two identical atoms linked by a single bond. You see, if covalent radius must be there, means it must be a single bond. It must be a single bond, first one thing. Then it must be internuclear distance, two identical atoms. They given that formula to find the covalent radius is nothing but r radius of covalent by distance of the two atoms or diameter. We can also tell that by 2. It is a formula to find the covalent radius. The bond length between two atoms in hydrogen. For example, we'll take the bond length. Already told that the bond length between two atoms in hydrogen molecule is 80 picometers. They are telling that the distance between the bond length between the two atoms in hydrogen atom molecule is 80. They are telling that it is 80. We want to find out the rate, means we have the formula RCO. Radius of covalent is d by 2 is nothing but they are giving that the bond length is nothing but 80 divided by 2 will get 40 picometers. Okay, and it is nothing but covalent radius. Next we are going to talk about van der Waals radius. Okay, van der Waals radius. Van der Waals radius. Van der Waals radius, you see, we want to talk van der Waals radius. You take any two neighboring atoms. You see, for example, we take chlorine, Cl2 H2. Okay, Cl is nothing but, correct, no, 2 Cl 2 hydrogen. I am not talking the distance between these two atoms. I am talking that the distance, the bonded. Can you understand? It's the radius. No, the one of the distance between two similar adjacent identical atom of neighboring molecules. You see, I am telling that neighboring molecules of, this is nothing but van der Waals radius. I will talk that VR to understand you. Of one of the distance between two adjacent identical atoms of neighboring molecules. I will write the definition now. One of the distance between two similar adjacent identical atoms of neighboring molecules. Van der Waals radius only for noble gases. Please, you want to remember, it is applicable only for noble gases. Okay, we don't define covalent radius or ionic radius in metallic radius. Okay, only van der Waals radius will only for noble gases. I'm taking this example that you can assess chlorine, hydrogen is not a noble gas. No sir, I'm giving a certain example, okay, to understand you. Taking the chlorine and hydrogen, you see, it is two similar atoms identically it is neighboring atoms. It is neighboring atoms. 1/2 of the distance. See, 1/2, correct? No, it is the distance. Okay. Next we are going to talk about metallic radius. Metallic radius. Metallic radius. The name only tell it is metal, correct? No, name only tell it is a metal. When come to covalent, it is non-metal. When metallic, it is metal. Okay. When van der Waals will taking in neighboring atoms. Okay. Neighboring atoms ಅಂತ ನೀವೇನು ಹೇಳ್ತೀರಾ? ಪಕ್ಕದ ಮನೆ. ಓಕೆ. ಇವಾಗ ಏನಾಗುತ್ತೆ, ಈ van der Waals ಇನ್ನೂ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ಬೋದು. ಏನು ಹೇಳ್ತೀರಾ, ಇದು ಟೆಗ್ ಆಫ್ ಬರುತ್ತಲ್ಲ, ಟೆಗ್ ಆಫ್ 2 ಮೆಂಬರ್ಸ್ ಇದ್ದೀರಾ, ಪರ್ಸನ್ ಎ ಪರ್ಸನ್ ವೈ. ಓಕೆ. ಏನು ಮಾಡ್ತೀರಾ, ಟಗ್ ಆಫ್ ಇದು ಸೆಂಟ್ರ್ ಪಾಯಿಂಟಿಗೆ ಇಡ್ತೀವಿ. ಮೀನ್ಸ್ ಎಕ್ಸ್ ಮತ್ತು ವೈ ಟಗ್ ಆಫ್ ಮಾಡ್ತಾ ಇರಬೇಕಾದ್ರೆ ಏನಾಗುತ್ತೆ, ಈ ಇಫ್ ಎಕ್ಸ್ ಈಸ್ ವೀಕ್ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ವೈ ಈಸ್ ಸ್ಟ್ರಾಂಗ್, ಈ ವೈ ಏನು ಮಾಡುತ್ತೆ, ಡ್ರ್ಯಾಗ್ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ, ಕರೆಕ್ಟಾ? ಈ ಡಿಸ್ಟೆನ್ಸನ್ನೇ van der Waals ರೇಡಿಯಸ್ ಅಂತೀವಿ. ಅರ್ಥ ಆಗ್ತಾಯಿದೆ? ಸಿಂಪಲ್ ಲಾಜಿಕ್ ಇದು ಅಷ್ಟೇ. If it pulls, it will become van der Waals. Next we are going to talk about metallic radius. It is similarly I am taking that 2 atoms, 2 metal atoms. I want to take that atom now. I want to take 2 metal atoms. The internuclear distance distance between 2 atoms, internuclears. You see, this is called quite commonly bond length, or we can tell diameters. You see, if you understand, if you take 2 copper, I'm taking that copper, that is Cu2. Okay, this is another one. 2 coppers is bonded in bond. I'm not talking now a bond order. Internucleus means, you see, if you talk that in covalent it is overlapping, correct? No, when it is a covalent radius, when come to van der Waals, it is neighboring, means it will be far, neighboring, correct? No, it is covalent radius, it's of van der Waals radius. Here you see, it is it's just connecting to 2 atoms. It will be a same metal or different metals. Okay, same metals or different metal. Internuclears. It is inter. I'm talking, it is inter. Here also I take, this is a inter, correct? No, inside. This is inter. Do you understanding here? Okay. I'm going to write the definitions. I'm taking copper. No, copper. If you take the bond or internuclear distance is 256 picometers. Then what is the formula to find that radius of copper? I'm taking this radius of copper is nothing but internuclear distance by 256 divided by 2 is 128 picometers. Now I am going to talk that term. You see, one of the one. See, I am taking this 1/2 of the 1/2. I am taking this. You understanding? I am not taking this. This is in covalent, it is in metallic. 1/2 of the internuclear distance between 2 metal atoms. I shown here covalent radius, van der Waals and metallic. Okay, next class we are going to study about ionic radius.